We have quite a few ways to create mattes for objects in your scene. In previous lessons, we've color corrected whole render layers separate from other render layers, but what if you want to color correct a specific model or a part of a model after you've rendered? For that, we have a great tool called CryptoMattes. Enabling CryptoMattes will create a random color pass of every model or shader in your scene. On our guitar view layer, at the bottom of the list of passes here, let's activate CryptoMattes for both object and material. Back in compositing, let's bring in a fresh render layer node and set it to the guitar layer, and click the Render Active Scene button. Now we've got all these CryptoMatte sockets. To use them, we'll need a CryptoMatte node. Under Mask, it's the first node listed. Let's drop that in and plug in the first Crypto Object socket. Now this view isn't very useful, but let's view the Pick output socket. Now you can see every object has been assigned a random different color. This node lets us pick one of those colors and use it as a matte. Click on the little Add button and pick something in the scene. When you look at the matte output, you can see that object we picked is now an alpha channel ready to use. You can click the Add button again and again and keep adding objects to the matte, and you can also use the Subtract button to remove objects. Okay, but look at the amplifier. In the CryptoMatte, it's all mostly one color. What if we wanted to affect only the fabric covering of the speaker? When I created the amplifier, I made it mostly a single model and applied different shaders to specific parts, like the fabric front or the metal plate behind the knobs. How can we isolate mattes for those areas? If you switch this drop-down menu from Crypto Object to Crypto Material, now you can see the colors assigned for the different shaders. And there you go. Now the fabric front of the amplifier is selectable. You can also see where I use the same metal shader on the chrome parts of the guitar by all the pieces that are the same color. This is the power to adjust specific shaders after rendering. It's a really useful feature. Next up, we should talk about shader AOVs. These are shader-specific mattes you can render from 3D. For example, when we use the CryptoMattes, we very easily got a matte for the body of the guitar as a whole, but not for the worn-away paint. We can use shader AOVs to create that matte for us. Let's jump into the shading workspace and select the guitar body. Down here in the shader nodes, the worn-away paint is coming from this first color ramp. The second one's creating the bump. Let's hit Shift-A, go to Output, and pick AOV Output. Plug the color ramp directly into that. Now we have to set it up as a render pass. Again, make sure you're on the guitar view layer first. This is easy to forget when you're constantly jumping around between the various view layers, 3D, compositing, and so on. In the Passes menu, scroll to the bottom to the AOV panel. Click the Add button, and let's give this pass a very specific name, like guitar_paint. In our AOV output node, let's put the exact same name, guitar_paint. Make sure these names are identical, even upper and lowercase letters. Back in compositing on our guitar render layer node we recently brought in, there's our new socket. Click the Render Active Scene button again. Once that's done, let's view our new paint matte. It looks great. And something to note, it's also included the alpha channel of the entire guitar body for us. Let me show you why that's important, especially if we didn't have the CryptoMattes already activated. First, let's use this matte to change the paint color. Bring in a hue saturation value node, connect it to the main image output. This lets us shift the color as we've seen in earlier lessons, but it shifts everything. Plug in the new paint matte to the factor, and now it's only affecting the guitar's paint, exactly as we wanted. But now say we want to change the color of the wood, not the paint. Okay, let's try an invert color node. That's changing the wood color, but also everything else in the scene again except the paint color. That's not what we want. If we view the invert node, we can see why that's happening. When it inverted it, it turned all this black area into white along with the wood of the guitar, which means, yeah, of course the color correction will affect everything else now. We need that to stay black. And that's where we can use that embedded alpha channel. Remember the separate color node we used in the alpha channels lesson? Let's bring that in so we can access the alpha of the paint layer. Click through it until you get to the alpha and you'll see it perfectly. Next we need a little math. 1 times 1 equals 1. Pretty basic. And we have white areas of the paint layer and white areas of the alpha layer. White equals 1. Multiplying those white areas together won't change anything. 1 times 0 is 0. That means after our invert, where it turned all the outside area white, if we multiply that to the wide open areas of the alpha channel, it should go black. Under Utilities, bring in a math node and drop it in line with our invert. Set it to multiply and plug in the alpha. And boom, the magic of simple math. We now have a perfect alpha channel for the wood areas of the guitar. So now you see how you can create an alpha channel from any texture, material, or shader you're using in your shader nodes. And the last point I want to touch on is a big one, deserving of its own course: rotoscoping. Rotoscoping is drawing a shape using points and curves and using that as a matte. In our View window, we can switch it from View to Mask. Let's click the New button here at the top, and now we have a mask layer called Mask. Let's rename that to Guitar Neck Mask. Down in the viewer, hold down Control and click and drag, and you can see a handle being drawn perpendicular from where your mouse is. While continuing to hold down Control, let go of the mouse button, move somewhere else, and click and drag again. Now you can see we're drawing a shape, and these handles will let us adjust that shape. It's almost exactly like using curves in 3D. Let's draw a few more, keep holding down Control, and then when we're done surrounding the guitar neck, press Alt-C to close the mask. Now we can go around and adjust all these handles and curves. Let's get it looking nice and tight around the guitar neck. You can add more control points if you need to by simply holding down Control and click dragging where you need a new handle. To use it in compositing, add a mask node. It's not under the mask menu, it's under the input menu. You can select your mask layer from the drop-down, and there's a few options like feather and motion blur. Motion blur is useful if your mask is animated. Feather is an option on each mask point that lets you create a gradient fall off for the mask, or what's called a feathered edge. Select one of our control points and press Alt-S, and you can position the feathered edge wherever you need it to be. The feather button on the node turns the rendering of that feathered edge on or off. Let's drop in a hue saturation value node on our guitar image output and plug our new mask node into the factor. Now we're using that mask as the alpha channel, and our color change only affects the guitar neck. You can create as many mask layers as you want, set keyframes on almost all aspects of a mask. You can blend masks in different ways on the same mask layer, use different curve types for the fall off of the feathering, etc., etc. Like I said, this is a big topic deserving of its own course, and I really just want to introduce you to it here. Rotoscoping is, however, an essential compositing skill set. Some of the projects in my professional work have had literally hundreds of rotos in a single shot. You can create very detailed rotos to separate an object in the foreground, and you can even create things from scratch just using rotoscoping, like glows, shadows, even a fake Z-depth pass. It's also used all the time for split screening, like when there's multiple copies of the same actor in a single shot. And a lot of times we'll create rotos called garbage masks, which are very quickly drawn masks that are used for general color correction, or even separating parts of green screen footage to use different keying tools on different parts of the image. We'll get to green screens in a little bit. First, we got to grab some footage to use in the next couple lessons, and we have to kind of optimize it for visual effects work.